Hello, my name is Kepler Smith. This is a video for my ENGR 120 DC circuit analysis class at New Mexico State University. Today we're going to be talking about the breadboard and circuits. Circuits are the word used for a loop at which electricity flows through. Okay, voltage is going to be the main word that we're talking about today, which if we're using a metaphor for it, if a circuit was a river, the voltage is how powerful the water is or how fast the water is running through it. We're not going to be talking about anything else today, just whether that we have a voltage or not and whether we have an actual circuit or not. So whether there's water flowing in the first place. So first thing to talk about is determining whether there is water in the first place. We're going to use this plain wire as an example here. I'm going to take this and I'm going to be grabbing both sides of the wire. Do this.
You said everything but, and it was say you're in the 24.
And then let me connect the other side.
Short is same color.
Okay, so these two are connected. And when looking at this, there is nothing stopping the flow of the electricity in the circuit. So when we look at this, there's no resistance, as we like to call it, in this circuit, okay? Electricity is flowing from the red to the black without anything stopping it. Because of that, we get zero resistance in terms of ohms is what we like to use as the word to that resists electricity in circuits. Now, a breadboard works very similarly to this one wire. We have columns right here. We have rows. In this breadboard, these two middle sections, the columns are important. Why are they important? Because this breadboard has a sort of hidden wire that works just like this, going along this entire column. So from column 19, from A to E, there is going to be a hidden wire going across it. As evidence, I'm going to be putting in this wire, and all in column 19. And we're going to attach these two leads onto it. And much like what we had before with just using the singular wire, we should be getting a circuit that shows zero resistance, which is again what we are seeing. Zero resistance, nothing is stopping it. Now, what if we were to do it on the same row? So it's on the same row of A, and what we want to check is if there is any flow through it. How do we know that there's no flow through it? Well, simply speaking, it's going to be just like as if we had these two in the air. Currently, there is nothing allowing electricity to pass from one to another. As this shows, this is 0.L mega ohms. And that just basically means that there is so much resistance that they can't even read it. That the resistance is near infinite in a sense. And because of that, nothing's flowing, because the air is most literally stopping it from flowing. So, if we were to put these on when the connections are on the same row instead of the same column, we can see that we are again getting that same reading of what is a near infinite amount of resistance that it just cannot read, and there's just no passage of electricity, meaning that there is no flowing of water to the second end of the circuit. Now, you need to think about this breadboard is that the top and bottom is a little different to the middle section. Instead of energy flowing from the top to the bottom on these middle sections, so per column, over here we can see that when we put them on the same row, just like what I had done before, we are getting zero resistance instead of infinite, which means that the wire is now going from left to right on this top. And if we were to check by the column instead, we are getting that near infinite again. So the last thing that we want to check is look at this resistor right here. This resistor doesn't have an infinite amount of resistance like the air does, but also doesn't have zero, just like a plain wire does. So, if we were to put these into these two different columns, we should be seeing that this red wire goes through the column. Oh, if I put in the right one, is going to be going through the column on this red, up to the resistor, flowing through the resistor, up to this right here, and it should be flowing through. So we should be seeing some form of resistance, but not an infinite form. And if we look over here, that is again what we are seeing. We are seeing some type of resistance presence instead of an infinite amount. So those are the examples of how a breadboard works and how the flow through the breadboard works, just like normal wires do. Thank you for watching.